Okay, so this is Wednesday of week 14. That means we have today, Friday, 3 more class meetings, a little tiny thing we like to call the final, and then you're free. We're almost there. So my hat's off to you for being here. It's definitely a slog. I wanted to talk a little bit about the delimited file stuff and taking a look at the reference I directed you to. I think it could be misleading in some of the more advanced stuff it throws that I didn't intend to happen, so I'll talk about that some. But I would be keen to hear your questions if you got them for me. So many of you have grown accustomed to using Vim. That makes a wonderful gift for relatives. A little Vim in a box under the tree. Just provide a little cheat sheet to go with it, right? Otherwise they won't see the value in the gift otherwise. That's what my kids are getting. Vim and algebra problems. Right. So let's see. Let me go ahead and create some data. How about, what's a good theme? How about mountains? Give me a mountain. The name of the mountain, let me clarify here before you run out. Rushmore. It's more of a mount than a mountain, but I'll accept that. Okay, Rushmore. How high is Mount Rushmore? I think it's, isn't it about 82,000 feet? I think it's 82,000 feet, if memory serves. You gotta, it's on the edges of the atmosphere. You have to actually wear a spacesuit when you're on top of Mount Rushmore. And how many shipwrecks are on Mount Rushmore? I think there are five, that's what I remember, 5 shipwrecks. Okay, give me one more mountain. Huh? Is that right? Is it Helena? Mount St. Helena? In Washington? St. Helens. Is that right? Someone, I don't know why I'm having said that. It just doesn't look right to me. Mount St. Helens. All right. I guess I'm so accustomed to seeing the Saint abbreviated. Well, no, let's just spell it out because we're programmers. I don't know what that means, but how high is that? 300 feet? And it wasn't that big a volcano. And of course, during the Viking period, there were quite a few shipwrecks. It was treacherous. All right, that'll work. So let me split it this way. Write a little code here. We want to include fstream. And we want to open the file. Hang on. An input file stream. We have to give it a name. Mountie. And we'll specify the file we're opening. All right. I'm going to create some variables. I have a string that I need for the mountain name. I have a string, I'm just going to call it my everything string. And then I have an integer which is the altitude or height. Let me use the consistent naming here, the mountain height. And we have an integer for the number of shipwrecks. All right. So let me go ahead and just write a little bit of code that's consistent with that reference that I gave you all. While you do a get line, and the first thing to read in is the mountain name. How do I want to actually move that over. Hang on. Doc. Resize pane. Resize pane dash L. Alright, so if I say resize pane dash L 8, well, that didn't do a darn thing. Oh, that's because I did it in Vim. Resize pane dash L 8. There we go, a little better. Okay, reading in the mountain name, and, excuse me, that's not quite right. Reading in from Mountie, that file, reading into the mountain name, and reading up to and including the pipe character, which it'll gobble up and throw away. And shoot, I can't quite get it. Let me get rid of the numbers for a minute. All right, so that's the line. It isn't all that attractive. But let's pull it apart. The get line part, I think, is probably the most understandable. Let me pull that out so we can look at it. So that's just a get line. It's getting it from the input file. It's reading in. Get line always works on strings. One mistake that some people do is they'll throw in an integer here instead of mount name. They might put, say, mount height, which is an integer, and getLine doesn't work that way. getLine specifically works with strings because it wants to read a sequence of characters and put them somewhere, and it always wants to put them into a string. And then the last argument is where it should stop reading. It should stop reading once it encounters that character, in which case it just discards that character. It is optional to put that there. What if I don't put that there? Then what? It'll stop at a new line. In fact, if you do this, that is the exact same thing as not putting anything there. All right? But in this case, we want to stop at a pipe, so we have that there. This whole expression here returns the stream that is being operated on. And what I mean by that is Mountie is the stream that we're working with. No, that it doesn't have to be Mountie, right? I can do cin. I'll just get it from the keyboard. In this example, if I had cin here, then the result of this expression would be cin. Now, when I say the result of that expression, I use that term clinically because the result of this expression is an integer. You all are very comfortable with that and don't think twice when I say that. Okay, the language looks at this as an expression in the same sense that it looks at this as an expression. It does some sort of calculation, some sort of algorithm, and then there is a result that sits there. In this case, the result is an integer that happens to be 9. In this case, the result is an input stream, which in this case would be cin. but I'm not dealing with cin, I'm dealing with mounty. So the result of that expression is mounty. So just as I would say 5 plus 4 becomes 9, get line with that particular get line becomes that, right? Now we can do something with the 9. For instance, if I had plus 6, then we could add 6 to the 9. I have mounty. I want to do something else with mounty. I want to ask it a question. Are you at the end of the file? And that'll be true or false. And what I want to do is I want to create a loop where I keep looping as long as I have not hit the end of the file. So as long as that thing is not true, I want to keep looping. All right? So now when I put this entire expression together, it's going to do this get line first from here to here. The result, when it's done doing the get line, will be mounty, and then it's doing EOF on mounty, and I'm negating it. So I will loop. I will read in a string up to a pipe. Then I'll ask to see if I've hit end of file, and as long as I have not hit end of file, I'm going to loop. So it's a little hard on the eyes, but that's kind of what's happening behind the scenes with all that. So that is the mountain name here. That's the first one. We need to read in the second one. And when reading in files, your safest course of action is always to read everything in as a string, and then if you need to do a conversion, you do a conversion after the fact. Okay. So I will do another get line. I want to read in from mounty. I called this string everything because I'm going to basically read in everything else using that string. I'm going to reuse it over and over again. I just need it momentarily long enough to be able to convert, in this case, an integer from it. So this will read in the height. Oops, add a semicolon. Now I do the conversion. So I say that I want the mountain height, which is an integer, there on line 12, equals, and there's a nice easy function that converts a string to an integer, and I just pass in the string I want to convert to an integer right there. And then last, I need to read in the number of shipwrecks. So I have, once again, I'm going to use everything. And this is a big mistake that a lot of people make. Why is that a big mistake? This is for the number of shipwrecks. It ends with a new line. Yes, exactly, right there. A 5, and then there's a new line. Or in this case, a 45, then there's a new line. So I either want to specifically put the new line character there, or knowing that get line defaults to a new line, I can just do that. Either way is fine. Now I want to convert it to a number. So I say that the number of shipwrecks equals S2I, everything. Now, if I want to, now I've finished reading in an entire line, do something with the, I'll call it a record, an old traditional database technology, terminology I should say, not technology. These would be called fields, and this entire thing would be a record. Here's one record, here's another record. Each record has 3 fields. So that's why I'm saying that. What I probably did in the example reference that I directed you to was something that looked really funky, like, well, actually, let me see what I did. Yeah, I do something like this that you've never seen before. So I have this AP. We see this. We don't know what an athlete is, but you have night, date, time, weapon, right? Athlete's just some class. But we have this asterisk, which we haven't really seen, and we have this new we haven't seen. So let me talk a little bit about that. Let's create it. Let's actually go ahead and create a class. Let's just go hog wild with this example. Class. Let's see. What do we want to call this? What does this? I guess it's a mountain. Private. The mountain has a string for its name. It has an integer for its height, and it has an integer for the number of shipwrecks. Then the public is, we'll create a constructor. It's going to take a string for the name, an integer for the height, an integer for the number of wrecks. Let me write that constructor really quick. Name. So following, we use the initialization list. Again, let me go ahead and talk out loud the process. Colon, we list all the private data with empty parentheses, name, height, num shipwrecks. As I examine lines 10 through 12, those are all my data. Now I just have to say what I'm initializing them with. Initializing that with N, I'm initializing that with H, and I'm initializing that with NW. Okay. Let me go ahead and create this. Using something that's more familiar to us. So this is mount name, mount height, I'm going to just zoom in like this. And the last one is number of shipwrecks. All right. So there's a problem with me doing this way. And to get at the problem, let's look at a totally different example. So we can use for loop. For int I equals 0. Come on. I is less than 5 plus I. When does the variable a come into existence? It's not a trick question. Line 43 is when the variable a comes into existence. Now here's the more interesting question. When does a go out of existence? And let me ask the question a different way. How many times does the letter A come into existence? 5 times. All right. So if A is, that's correct. So if A comes into existence 5 times on line 43, at what point is it going out of existence 5 times? Say that again? Yeah, so it's going out of existence repeatedly at line 45 when we hit the closing curly brace. So I would say that the scope of A is from lines 43 through 45, right? So now let's come back up here. On line 35, what I want to do is I want to create two mountains. But the way I have this code written, on line 35, that's when my mount comes into existence. When does my mount go out of existence? The very next line, right? So this isn't going to do what we want it to do. There's no way for me to do this to create two mountains, because any mountain I create anywhere in that loop is going to go out of existence each time I hit the bottom of the loop. And in fact, I might want to do stuff like this, right? The idea is, the reason for the loop is that, isn't it nice to create a general algorithm so whether I have one mountain, two mountains, or 1,000 mountains in that file, I can have one nice tight loop to read in mountain after mountain after mountain, and then after I've read them in, I can do something with my 1, 2, or 1,000 mountains. Well, given what we know now, none of that works, because anything we create in the loop dies at the end of the loop and definitely does not exist after the loop. And if we go to our joust example, based on looking at that IO tips, you're going to want to create a loop to create those two knights, so that after you read them in, your two knights in with the loop, that after the loop you use them to do the joust, right? And given what we know now, that simply doesn't work. Line 37 won't even compile because my mount does not exist on line 37. So there are a couple ways to deal with this. I would counsel that the easiest way is to not use a loop at all. And I would do it very similarly to how you did the previous project. So how did you create two knights in the previous project? You didn't use a loop. What did you do? You asked the user 2 times all the same questions, right? You didn't have a loop and loop 2 times asking the user questions. You basically asked 5 questions for the first knight, created a knight. You asked 5 more questions for the second knight, created the second knight, and then you went on and did your joust. Yes? I think that's the easiest way to deal with this, except rather than prompting the user, you're opening a file. Open a file, do your 5 to 8 get lines, probably what, like 8 get lines? Let me see, name, stamina, and then there are 3 for one weapon and 3 for the other. So that's 8 questions. Ask 8 questions, create your first knight. Ask 8 questions, create your second knight. That's the easiest way to do it. Okay? Yes. But I'll talk about alternatives here in a minute. All right. So that's what I'd recommend. Now you get the added value stuff that you're not required to do at all. This idea of using a loop to read in a file and creating 1, 2, or 1,000 of things is not an uncommon problem. It's extremely common to want to do things like this. Clearly, we're not stymied by the language, and we're given methods of doing that. It does require a bit more advanced programming, which if you go on to 211, you get in very deeply. But I'll go ahead and give you a preview of it here now. And what I would do in this example is I would create, well, if I know I'm going to need, oh, how do I want to do this? I'll give you the full-blown method. I would not create a mountain. I would create something called a mountain pointer. And my mountain pointer, the asterisk, you literally read as pointer, the word pointer. And the variable, my mountain pointer, is not a mountain. It is basically, it's a number, and that number that is designed to hold an address, right? So your computer has addresses going from 0 to God knows how high the number goes nowadays, into the gigabytes. And you can put an address in there, and the address you put in is somewhere in the machine where there's an actual night. And what I can do is I can create a night using this operator called new. I say a new what I want to create. I can create a new float variable that has 3.14. I can create a new integer that contains 42. In this case, I want to create a new mountain. And the way you create a mountain depends on the constructor you have, or constructors. Show your choices. So if you recall, I created a constructor that takes a string and 2 integers. So here I would say some string, some integer, another integer, right? So these are variables that I've created probably somewhere. This statement will actually find available memory on your machine and will set aside enough memory for a mountain, and it'll go ahead and run the constructor, and you'll have a nice mountain object. It's a little bit different. It's very similar, but a little bit different than saying this, mountain. I won't fill in all the information. This is creating variables the way we've been doing it, right? Float FL, mountain, my mount, and then you provide the 3 pieces of information. The problem with this method, as we've already seen, or I should say not the problem, but the limitation is that it's constrained by the set of curly braces that it appears inside of, and it's going to die as soon as it hits the closed curly brace. This, on the other hand, this mountain that I'm creating will exist until my program ends. There's no sense of dying when it hits closed curly braces. It goes out, finds free memory, creates a mountain for me, and it is going to exist until the program ends, or until I manually tell it to go away. So this statement here, all 3 of these actually, are woefully incomplete in that what this thing does is it gives back to me the location in memory where it put the thing. And line 31, as it exists right now, it'll create a mountain, it'll give me back that number, and then I don't have it. I've lost it forever. It's like me saying 5 plus 4, right? Well, the answer is 9, but where did I store the 9? Well, I didn't store the 9, so it's lost for all eternity. Same thing here. It set aside room for a mountain. It gave me the address of where it is, but I didn't save that address, so I have a problem. So I have to put some sort of variable here to grab the address that it gives me, and that's what this is. So that's saying this is designed to hold the address of where a mountain is stored. So what I would do is say my mountain pointer. Get rid of those. Now, making this whole thing complete, if I have more than one mountain, in this case, if I have 2 mountains, I can use an array. So I come down here and I say my mountain pointer, whoops, and I need to put some sort of variable here, equals new mountain, whoops, I'm going to put this on 2 lines. The very first time through this loop, what should FDSA be? And the second time through the loop, what should it be? Exactly. It should be 0 the first time and 1 the second time, right? Because I've got 2 of them. I created enough room for 2 of them here. And this assumes that I know there are only 2 mountains stored in the file. All right, so let's create a counter. Int counter equals 0. That solves a 0. How do I make sure the next time through it's a 1? Add 1 to counter. So now the second time through the loop, that'll be a 1. And it'll allocate us room for a second mountain in memory somewhere. And now after my loop, I'm free to use my mountain pointer sub 0. We have, what we've been doing is k1.display, that kind of thing. When you're dealing with pointers, there's a different symbol that you use. All right, so I can go ahead and do things with my mountains after the loop. So if I read in my 2 knights this way, then I can go ahead and manipulate my knights this way. So this is the, whoops. Okay. This is the I'm a professional programmer way of solving this problem. And again, there is 0 requirement for you to do this for this project. If you want to do it straightforward, easy way, then what you do is you just simply ask 16 questions of the file, 16 get lines, and don't use a loop at all. Questions that this brings up? Yeah. Yes. Yeah, that's a good question. I think it will. So if I just did that, I believe that should work as well. Let's test it out. So let me leave it in. I'm almost certain it does work. I'm a little bit, yeah, this is a little bit of get off my lawn kind of stuff. So my old habits die hard, but it should work. So what we'll do is, let me put a cout statement in here. Reading mountain counter. And there is no display function. I'm going to comment these out because I haven't written a display function for mountains. Let me do this. Let me come over here. Let me quit out of this. G++. Oh, I was playing around with this code down here. All right, so that worked and read into mountains. So now let me go with your simplification. I'm actually surprised. I would have thought that would have worked. Oops, what in the world did I just do? I think I accidentally closed my pane. So why didn't that work? So I guess the answer is that doesn't work. What if I do, let me try a variant. Yeah, so it looks like this way you've got to ask some sort of question of the stream. So here I'm saying, as long as the note I took out this negation, so in this variant, as long as the stream is good, then keep reading stuff in. It's a good question why I have this in the loop at all. Let me try taking it out of the loop. So let me say mounty.good. While it's good, I want to read. And what I'm going to do is I'm just going to do this get line inside here. So let's see what happens when I do that. So what happened is it did an extra read. It went through the loop an extra time, which I didn't want it to do. So the question is, well, why in the hell is this, whoops, let me zoom in here. Why is this version of it going through the loop a third time, whereas the version I had originally didn't go through a third time, it only went through 2 times? And the only difference is I actually do a read inside the condition there for the while. And the reason is so let me see, how can I do this? Read, actually let me do it a different way. All right, so here's our data file. Which version do I want to do first? Let's do the version that's not working quite right. Line 36, it reads up to, I'll use a little caret. After line 36, that's what it wants to read in next. Everyone line 37 now. After it does line 37, that is the next thing to be read in. Yes? Then I do line 39, makes it there, and then I do line 41, which reads in the 5, gobbles up the new line, and that's the next thing to be read in. After line 41, that is the next thing to be read in. So we hit the bottom of the loop, we go back up. Is Mounty still good? Yes, it is. So now we do line 37 again, which puts us right here. We do line 39, which puts us right here. We do line 41, which reads in the 4, the 5, gobbles up the new line, and now it's ready to read here. Goes up to the very top, line 36, and asks, is Mounty good? And the answer is yes, and this is the reason why. What we've done is we've read up to the end of the file. Yes? There is no more to read. However, the input file stream, Mounty if you will, does not know that it's at the end of the file. The only way you can know if you're at the end of the file is if you try to read and there's no more to read. All Mounty knows is I asked it to read in on line 42. I asked it to read up to and including a new line, and it was successful. As far as it's concerned, everything's still good. It's only when you try to do one more read and it goes, whoa, 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 there's nothing more to read. Wham, it throws a flag and says, I've hit end of file. So in order to make the end of file flag true, or to say it differently, in order to make the stream not good, you have to do something that gives it heartburn. And the thing you have to do to give it heartburn is try to do a read when there's nothing more to read. So that's why this line, why the get line is actually put inside the while loop, because when I'm on, if I look here, I've read this line successfully, I've read this line successfully, everything's great. The stream is still good. Now I'm asking it on line 35 to read in a string up to a pipe, and it goes, immediately it says, I'm at the end of the file, there's no more to read. And then it puts the stream into a bad state. And this get line fails. This get line doesn't do anything. It tries and it fails miserably. And now, but it still returns Mountie. Now we ask Mountie, are you good? And the answer is no, I'm not good. I just try. I had so much trust in you, and you just made me try to read when there was nothing more to read. Okay. Fortunately, it doesn't take it personally. So that's why the get line's actually inside the while loop, because you actually have to try to read past the end of the file for it to go bad. And all this code, of course, will be posted with the notes so that you can ponder it. Any other questions? I haven't checked this in a while. Let's see if we've got any. 9.111, yes. Nothing there. All right. I am not going to be in lab today. I have some stuff I need to do, but Jordan will be there. Again, he's always sitting there at that table, so he should definitely be able to help you. There was someone had asked about lab 23, I think it was, about strings and enumerations that I had due on Friday. I just forgot to update that. It's due Wednesday of next week. So the labs you need to concentrate on are the reading from the file and doing the weapon class. Okay? All right. And I will have office hours, but they're being pushed later. My office hours today will be from 2 to 3.